All right, let's talk about texturing real quick. So, um, I have a rig set up for each model, and a part of setting up the rig includes labeling. So there's group tags in here. So like this, for example, if we were to select that. So this right here is a group. We just named it Piston, for example, which now now I'm questioning that name. But anyways, so we model the things and then we group them, and I have a section for rigging and animating. Now the grouping is a particular interest. There's two types of groups. So one group is used for the physics. So like this engine block here isn't going to move. It's going to be stationary, or it's going to move together anyways. So and then everything here is like locked together. So they're treated as one physical part. And so that's what this grouping is for, but it's not necessarily the same for colors. So and a good example here is in this engine center, you see all this stuff. Well, I don't want all of this to be the same color. So we have different groupings. So, okay, we start with that. Then let's go here. Now what I have set up is I pull in this object. So it's the same thing, the completed model. And then I have some code here to just initialize an array. So it just creates an empty array. And then we have to split out the groups again. So this is going to be defined as one color. This is going to be defined as another. And so we have certain limits of what we can smash into the texture right now. So we get this, we get this, we get this. And so, we have all of these. And so what this will do is it runs through and it adds that name to the texture, and then run it we run it through and relate it to its position on the UV. So we take the UV and then we run into cops here. And so what we have here are textures that correspond with the shader function. So there's the base color map, and it's not actually going to be red, but these are IDs. So what we have is we pull the UVs out, we have to convert it, and then we have to query the geometry here. And so that's what we're querying, this position. And then we extract what is it called? The attribute from that location there. So we take the UV and the prim, and we grab the IDs in that spot, and then we have to translate it. We have to convert it into something that the file can understand. So it has to be normalized down to 0 to 1. So we divide it, and we get the output. We just stuff it into the R channel. So, and that's what you get here is, so all of those color assignments that we were doing up here become one of the numbers. It's 191 different possibilities. We tend to only use like um, three different ones, but anyways, I went kind of nuts, and so you can stuff a lot into the channel. So you can do 191 different shades of red, which represent 191 different colors. Similarly here, this is passing um, compatible textures that can receive shadows. So for example, you'll see like there's some black spots there. Those things can't receive shadows, or they're not supposed to anyways. Same thing with the shade map. It's kind of like ad nauseum. All this is the same. Now there's a different one. Um, some of them are different. So like the shade 2 mask actually combine with a pre-existing halftone pattern. So I take the texture and then I blend it together, um, to basically do the same thing, but it's meant to be a mask. So we basically pass into all the channels. So instead of just passing it into one, we pass it into all three channels. So if it's a mask, it'll be black and white, and it will probably have the same kind of logic, except it will stuff it into all three channels. So the shade mask here adds a halftone pattern. You kind of see like the dots everywhere. And so that only happens on shadow 2 right now. So the halftone pattern shows up whenever there is a dark enough area. So there's shade 1 over here for like light shadows, and then there's shade 2 for like super dark. Um, there's one other thing that's not on here, and it's this pattern one. And so this is kind of like the boundary of my exploration where I haven't gone too much further. And this needs work because my normal maps suck. Um, this bake plain normals here. I'm using the Houdini thing to make normals, and let me see if I can look at them. So I don't think this is right. Um, Call me crazy, but I think there's something wrong with this. Fortunately, it doesn't matter all that much. So I take this normal file and then I pull it in. And so we do the same thing where we query the position on the UVs, and then we take that plain normal texture and we mix it with a formulation of a pattern texture. So I'll take a texture file like, let me open a new one here so I can just start looking for it. Okay, work. 1 second, let me pull this guy up. So here, I'll pull a pattern like this in, this wood pattern maybe, and then sample that just kind of on repeat, and then it will get applied to that normal texture. And so those patterns also include a normal map here. So I'm taking from this map and then blending it, which produces a pretty neat effect. You only see it in the shadows typically. So you only see if there's light and dark, and it'll kind of create that texture in there. So yeah, this was fun to convert that serialized normal into the correct digits there. And so, anyways, this is probably ripe with bugs and stuff, but it actually does produce a good result in the engine itself. So, okay, I'm trying to keep this under 10 minutes, but I got a 7. Go to Houdini real quick. So then with this is a different model, but all right, so you can see like this kind of has some grunge on there, like the lines here. That's coming from that pattern there. So that works. And then this one here doesn't have any pattern, it just has Boolean damage, so that's actual geometry. I'm going to delete that bone because you can't see it whenever you use the whole thing. Yep, yep. So that's basically how the colors come in. And I'm not going to go over the Unity part just yet. I want to keep this short for you.